Okay, so signals and emissions. Modulation is a process of adding information to a radio wave. To generate a voice signal, when you modulate the radio wave with your voice, if you're doing something other than voice, it happens in other ways. VHF, UHF repeaters typically use FM modulation. We're all familiar with FM. Frequency modulation or phase modulation is probably what you'll use as a technician. With frequency or phase modulation, the frequency or phase of the signal is changed in proportion to the volume of the audio signal. So louder will have a greater influence on the modulation than talking soft. The frequency or phase modulation, the frequency or phase of the signal is changed in proportion to the volume of the audio signal. An FM receiver detects this frequency change and recreates the audio. So what you see at the top there is you see a modulation envelope that is a AM signal on the top. So you'll see that the carrier stays the same frequency all the time. You see the carrier in the middle there. It stays the same all the time, and you transmit you modulate, you put the information on there by varying the amplitude of that carrier, and the carrier stays the same frequency all the time. That's AM. You split that in half and you get something else we'll talk about a little later. Constant amplitude, when you look at the bottom one there, you're looking at an FM signal. Frequency modulation or phase modulated signal. You'll notice that the amplitude is constant. It stays at the same level all the time. The information is portrayed on the changing of the frequency. So you'll notice that the frequency there, and these signals are lined up using the same signal. So you've got here where the AM modulation is at its lowest point, you'll see your frequency is bunched up there. And out here it's a little wider. And that's FM. And I look around the room and I see that everybody here probably already understands that. I mean, we've all been in electronics, right? Which type of modulation is commonly used for VHF and UHF voice repeaters? D, FM or phase modulation. Packet radio is a way to send digital information over the air. Packet radio, this is, it says digital information there. So it sends the information in packets. On VHF, this is usually done using an FM or PM signal. Some digital information is sent by changing the frequency of the audio. The information is sent in the form of marks and spaces. A VHF packet radio transmission with a data rate of 1200 baud, and there will be questions about baud rates on there, although some of that has just recently changed. Baud rates, let's see, 1200 baud normally uses a frequency of 2200 hertz for the space and 1200 hertz for the mark. 2200 and 1200, so they're 1000 hertz apart. What type of modulation is commonly used for VHF packet radio transmission? A, FM or PM, that is correct. Thank you, David. Amplitude modulation, or AM, is another type of voice transmission. AM varies the amplitude proportional to the voice signal. So when we look back, and doesn't show the modulating signal here, but you can see that the amplitude on that top one over here, you can see that the amplitude is going with the modulating signal. Now, AM varies the amplitude proportional to the voice signal. Single sideband is another form of AM. So single sideband. So AM was the thing way back in the day. That's what everybody did. That's what your radio signals came to listen to on your AM broadcast radio. And when they first started talking on the radio, that's what we used. And then single sideband came along. Well, actually, next came along was FM, and then single sideband started up, and everybody went back to AM again for comms. And there's a reason for that too. So single sideband is another form of AM communication. Single sideband is a better choice for long distance or weak signal VHF, UHF contacts. Narrower bandwidth and increased signal to noise ratio. Which of the following is a form of amplitude modulation? C, single sideband. Which type of voice mode is often used for long distance weak signal contacts on the VHF, UHF bands? C, single sideband. A single sideband signal may be either upper sideband or lower sideband, depending on which half of the signal you're going to take. Early radios used a 9 megahertz IF. I don't think anybody's designing anything with a 9 megahertz IF anymore. And it was easier to generate lower sideband below 9 megahertz and upper sideband above 9 megahertz. So we use 10 megahertz as the dividing frequency today. All right, so when you look at your chart, let's see if I can find it here. Okay, so when you look at, don't want to walk in front of that again. So when you look at your chart here and you notice 10 megahertz, the 30 meter band starts off at 10.1 megahertz. Okay, everything below that is typically lower sideband. Now there's an exception, and that is the 60 meter band is upper sideband, and it says that on here somewhere. Yeah, upper sideband right there at the bottom. Why they did that, I'm still not certain. But yeah, from 30 meters up, you want to always use upper sideband. One of the ways to tell when you're switching around on your radio, most radios are going to remember. So if you change bands, when you go back to the other band, it's going to remember what your settings were when you get there and set them back. So usually this isn't something you have to do, but in the initial setup, it is. But the way to tell, one way to tell if you're on the correct upper or lower sideband is that when you're talking or listening to somebody talk on there, if it sounds like Charlie Brown's parents, you probably got it on the opposite. Okay, so if it sounds like Charlie Brown's parents, then switch it to the opposite. You know, if you're on lower, switch it to upper. If you're on upper, switch it to lower, and you'll probably come in. The other phenomenon to watch out for, though, when you're playing on the radio, is that as when you get into HF, as you're tuning around on the frequencies, as you get higher and lower, it changes. You're listening to one signal, but when you're a little bit above it, it sounds one way. When you're a little bit below it, it sounds a different way. And you'll learn those sounds and you'll know which direction to go without having to sit there and fiddle with it. I never drank more water than when I lived in Florida. We use 10 megahertz as the dividing, somewhere around here, I got a clicker. Upper sideband commonly used on 20 meter VHF, UHF bands and on up. Lower sideband commonly used for 160, 80, and 40. You notice that it left out the 60 meter band there because it's kind of the black sheep, it does its own thing. The other thing about 60 is that it's the only band that's divided into channels. And there's a lot more to learn about that if you ever decide to start working 60 meters. There's a certain way you have to do it. Okay, AM versus single sideband. First drawing there on the top, you see that's your baseband signal. The second one, you see that's your full AM modulation. So you've got, remember that when you modulate something, you modulate through a mixer, and the outputs of a mixer is always the sum, the difference, and the two originals, okay? And through the magic of filters, you filter out the ones you don't want and leave the one you want. But with full AM modulation, you see you've got a response above, both above and below your baseband signal. And then you see upper sideband there and lower sideband in the next two. And you'll notice that the carrier frequency is completely obliterated from that because we don't want it on there anymore. We only want to transmit the single sideband, whichever one we want. Which sideband is normally used for 10 meters HF? Let's see, 10 meters HF, VHF, and UHF. A, upper sideband. Yeah, I always have to read that twice because 10 meters and then 10 megahertz. So I always end up have to read it twice before I say something. The audio of an FM signal sounds better than an AM signal. Okay. FM occupies a wider bandwidth than AM or single sideband. Single sideband occupies a narrower bandwidth than AM or FM, which is why it's generally preferred. Single sideband is typically 3 kilohertz wide, whereas AM is 6 kilohertz. And your UHF, VHF repeater FM signal is generally 10 to 15 kilohertz wide. And this is important because there's a setting on your radio for wide or narrow, and for your UHF and VHF repeaters, you want to have it set to wide. All right. What is a characteristic of single sideband compared to FM? Single sideband compared to FM. Let's see. Single sideband signals are easier to tune correctly. Single sideband signals are less susceptible to interference. Single sideband signals have narrower bandwidth. I'm going to go with C also. I agree with you. C, single sideband signals have a narrower bandwidth. What is the approximate bandwidth of a typical single sideband voice signal? I went over it pretty quick. B, yeah, 3 kilohertz, and then 6 kilohertz is your full AM bandwidth. Okay. What is the approximate bandwidth of a VHF repeater FM voice signal? Approximate. C, 10 and 15 kilohertz. That is correct. A disadvantage of FM compared to single sideband is only one signal. Okay, disadvantage of FM. So on this right here, this is, like I say, this is a DMR radio, but it does do analog repeaters also and analog simplex. But with FM, which is what this uses, is FM, as compared to single sideband, the biggest disadvantage is that only one signal can be received at a time, and it's a matter of the way the detectors work. So when two signals are present, only the stronger signal is demodulated. The other signal just gets lost because the radio thinks that it's interference or something. This process is called the capture effect. Which of the following is a disadvantage of FM compared to single sideband? B, only one signal can be received at a time. Some modes have wide bandwidths. AM fast scan TV, that's fast scan, that's not what you were asking about earlier. AM fast scan TV has approximately 6 megahertz bandwidth. That's huge. That's wider than the entire 2-meter band. 2-meter band is 148 or 144 to 148, so that's 4 megahertz for the whole entire band. And AM fast scan TV has a 6 megahertz bandwidth. A lot of information to transfer there. Analog fast scan color TV signals are referred to as NTSC. And for those of us who have always wondered, why did they take away our NTSC television broadcast? Well, now we know it's because of the bandwidth. They soak up a lot of bandwidth that could be used for spying. Whoops, I didn't mean to say that. NTSC, the National Television Standards Committee. What is the approximate bandwidth of a fast scan TV transmission? B, 6 megahertz. What type of transmission is indicated by the term NTSC? Analog fast scan color TV. CW is another name for Morse code, okay? If you were here when Greg came in, I was just happened to be listening to a local country music station. Okay, CW here doesn't mean country and western. It means Morse code. Okay. CW signals have a narrower bandwidth than AM or FM and have a really, really incredibly narrow bandwidth. The bandwidth of a CW signal is approximately 150 hertz. What did we say it was for a single sideband signal? 3 kilohertz, and we're talking about 150 hertz now for CW. Technicians have CW privileges on 80, 40, 15, and 10 meters HF. So even though the only thing you're going to be able to do on HF with voice will be 28.3 to 28.5 in the 10 meter band. But if you happen to be proficient with CW, you've got lots of opportunities available to you. Technicians also have CW privileges on VHF and UHF, but you're on VHF and UHF and microwave, you're open for anything that's allowed on those bands anyway. What is CW? D, another name for Morse code transmission. And does anybody remember, I think week 1, might have been week 2, but I think it was week 1, Bob sent out links to his YouTube and his Dropbox information so you could get that stuff. Did you notice that at the bottom there was the lights going across at the bottom? That was 73, right? Yeah. So that was Morse code for 73 with the lights. Does it have audio also? I never turned up the volume on my computer, so I don't know. Which of the following types of signal has the narrowest bandwidth? C, CW. What is the approximate bandwidth required to transmit a CW signal? Let's see, what is the approximate bandwidth required? B, 150 hertz. Morse code can be sent with a straight key or a paddle, and there's a couple of other different types of keys, but we're not going to talk about those right now. Straight key is what they used on the Titanic. So, for lack of being able to find a better example, but it's a straight key. I mean, telegraph key. Paddles are a little different. There's a single paddle or a double paddle. And the way the paddle works is you have to use it with a keyer that knows which side you're pressing. So you press the single key, you press it one direction, it will do a dit, the other direction it'll do a da. And it's switchable easily by it repeats if you hold it, if you got a keyer. And that's what makes sending Morse code easier with paddles and a keyer. The timing is a lot of time is mostly done by the keyer. The double paddle keyer is same way. It's just that you've got two paddles and you push either one of them toward the center, and it activates either a DIT or a DA. And they can be switched depending on if you want to operate left-handed or right-handed or upside down or whatever. A straight key has one set of contacts. DITs and DAs are done by manually closing the contacts, and you have to determine the timing. And there is, I would say that timing is critical, but I've listened to some of them on there and tried to decode some of it, and not everybody does the same thing. But the more accurate your timing is on there, the easier it is for people to understand you. The paddle has two sets of contacts, or if one, it just operates either direction. Connected to an electronic keyer. One set generates DITs, and one direction generates DITs, the other direction generates DAs. The electronic keyer assists in manually sending Morse code. And I've worked with both of them, and I can send my call sign with either one of them fairly easily, and I can send CQ, but I can't decode any of it. It's where the downfall comes. Decoding is definitely the tricky part. What is an electronic keyer? Right there, we discussed the electronic keyer. What is an electronic keyer? A device that assists in manually sending Morse code. That is correct. VHF, okay. So this is your takeaways. VHF, UHF repeaters commonly use PM or FM modulation. Only one signal can be received at a time. Single sideband is a form of AM. Upper sideband is used for 10 megahertz and above. Lower sideband for everything below that, except for the 60 meters. Narrower bandwidth FM, approximately 3 kilohertz. FM voice is 10 to 15 kilohertz, and CW is 150 hertz. Yeah, CW is a form of AM Morse code. The K shouldn't be there. Should be 150 hertz. Fast scan color television is 6 megahertz. Electronic keyer is used to assist in manual sending of code. And that is the end of that one. Right. Yeah. Right. Oh, yeah, I forgot about that. So, yeah, if you're using the digital mode for on any band, it's supposed to be upper sideband. And that's a couple of groups that